Assalamualaikum students. Students, in today's class, we are going to discuss electronegativity. What? Electronegativity. You know what is electronegativity? Electronegativity is the tendency of an atom. Tendency of an atom to attract the shared pair of electron toward itself in a covalent bond. In a covalent bond. Now, for example, these are two atoms. They're covalently bonded. There are electrons. The electrons are attracted by this atom due to its nuclear attraction. The electron is also attracted by this atom. So the electron cloud is equally attracted by both. The electron cloud is symmetrically distributed. How? Electron cloud is symmetrically distributed between bonded atoms. No permanent dipoles. What is the meaning of this? I'm going to explain it. Now, these two atoms, they're same atoms. They have same nuclear attraction for electron, equal. Same electronegativity. So electronegativity is directly linked to what? Nuclear attraction. Electronegativity depends on size of atom and nuclear attraction for valence electron. Now, down the group, number of shells increase, the size increase, down the group, size increase, nuclear attraction, size increase, nuclear attraction for the valence electron decrease, electronegativity also decreases. But across a period, what is happening? The size decrease. Across a period, electronegativity increase because there's more nuclear attraction. So if you look at periodic table, in the periodic table, down the group, the electronegativity decrease across a period, electronegativity increase. So this is lithium, the most electronegative in group 1, beryllium, the most in group 2, boron, carbon, nitrogen, oxygen, fluorine, neon. So if you look at all these, the most in group 1, the most electronegative in group 2, in group 3, group 4, group 5, group 6, group 7. But what about across a period? So which means the most electronegative, fluorine. One thing which is very obvious, the down the group electronegativity is less, across a period is more. If we look at hydrogen, at hydrogen, the hydrogen electronegativity of hydrogen is more than group 1, 2, 3, electronegativity of hydrogen is almost equal to group 4, electronegativity of hydrogen is less than 5, 6, and 7 groups. And second, this is fluorine, chlorine, bromine, oxygen, sulfur, Se, nitrogen, phosphorus, As. Look, down the group size increase. It's less electronegative. This is also less electronegative. But it has 2 shells. It has 3 shells. Look, it has 2 shells. It has 3 shells. Diagonally, this is more electronegative. Oxygen is more electronegative than chlorine. Like nitrogen is more electronegative. Like diagonally, it's true for all. Why? This is smaller in size, larger in size. So, what do you know? Down the group, less electronegative, more electronegative. Now, hydrogen is more electronegative than group 1, 2, 3, equal to group 4, less than 5, 6, 7. Like it's a rough guide, but it helps a lot. Now, if there is a bond between hydrogen and chlorine, now it is group 7. This is hydrogen. Group 7 is more electronegative. If it is more electronegative, what it will do? It will attract the electron cloud more. So if it will attract the electron cloud more, there are less electron and there are much more electron like this. It's kind of this. So if chlorine is more electronegative, it's partially negative, it is partially positive. The one that is more electronegative attract the electron cloud toward itself. The electron cloud is not in between. The electron cloud is more toward chlorine. Therefore, it becomes slight negative. Its nuclear attraction is more. It keeps the electron toward itself. It becomes slight negative. It becomes slight positive. Look, I have explained it here. These are the notes which are available on my website, Chemistry by Zeenat. And students, don't forget to like, share, and subscribe my channel, okay? Now, look, fluorine is more electronegative. It attracts the electron more. It's electron-rich region, electron deficient. So this is what? Partially negative. This is what? Partially positive. Slight. The sign is what? Slight. Slight. Like not full negative. Now, next thing. If electronegativity difference is more than 1.7, like look, fluorine and lithium, how much? 3. Huh? This is also more than 1.7. This is also more than 1.7. Ionic. But if the electronegativity difference is less than 1.7, but more than 0.4, look, if electronegativity difference is more than 1.7 ionic, if it is less than 1.7 and more than 0.4, covalent, but polar covalent. Look, what is the electronegativity of chlorine? 3, and this is what? 2.1. So how much is the difference? It's less, huh? The chlorine is more electronegative. It's how much? 2.1. It's I think 0.4. It's how much? No, not 0.4. Sorry, 0.7. So it's 0.7. So the difference is, oh, why I'm saying 0.7? Sorry, 0.9. 0.9. 2.1 and 3. The difference is how much? 0.9. So which one is more electronegative? See here. It attracts the electron cloud more. It becomes partially negative. Look at this. This is 2.6, this is 3.5. Which one is more electronegative? This. So will it attract the electron toward itself? Yes. Partially negative. The other is what? Partially negative. And the sulfur is what? Partially positive. Look at this. 3 and 2.5. So how much is the difference? 3 and 2.5. The difference is how much? 0.5? Slight more than 0.4. So again, this is more electronegative, this is less electronegative, more and less, more and less, more and less. The more is partially negative, partially negative, partially negative, and the central one is what? Partially positive. So these are in your data booklet. If Cambridge will give you these values, you must know that if the difference is more ionic, if it is in between 1.7 and 0.4, covalent but polar, has permanent dipoles. But if it is less than 0.4, the difference is not very huge. So their tendencies to attract is almost same. Like the dipoles will be like this. Look at this. Do you think there is so much difference or slight? Huh? Slight. So it's kind of no permanent dipoles. Like, look, is there hydrogen given? Yes. If you look, 2.1 and 2.5. So how much is the difference? 0.4. Right? So it is considered to be what? Non-polar. No permanent dipoles. You must know the down the group electronegativity decrease across a period increase the atom. Like suppose you have two atom, one is HOH. So which one is more electronegative? Oxygen. If it is more electronegative, partial negative, this is what? Partial positive. Partially positive. Why? Because the electron cloud is in between symmetrically? No. It is more toward oxygen. The more electronegative. Right? And you must know that we say the down the group electronegativity decrease. Look, phosphorescent A's are almost same, and they are same. So you must know that there are situations that even down the group the size increase, but still the electronegativities are not changing very large. They're not even changing. And maybe these values are up to one significant figure, so they're not that much exact. This you must know. And at the same time, you must know that if they are same, they tend, like the bond between P and S would be what? Polar or non-polar? No permanent dipoles. So if you have, suppose, aluminium with suppose fluorine, huh? Or you can say chlorine, just go for chlorine. Aluminium chloride. So which one is more electronegative? Chlorine is 3 and aluminium is how much? 1.5. Which one is more? Chlorine. So what the chlorine will do? It attracts the electron more. The electron cloud are exactly in between or toward chlorine. Toward chlorine, partially negative, partially positive, partially negative. Do you understand this? Now, after, like in this topic, I was totally discussing bond, right? Like, look, the bond between, suppose, carbon, oxygen. How much is the electronegativities? Oxygen is 3.5, carbon is what? 2.5. So which one is more electronegative? Definitely oxygen. So which one will attract the electron more? Oxygen. So the electron cloud is symmetrically or asymmetrically toward oxygen. Toward oxygen. So this become partially negative, partially positive, partially negative. These are called what? Permanent dipoles. But after bond, now we are going toward molecules. Yes, one thing more, this point, very important in the recent papers. Like, look, the difference here is how much? Just 0.9. The difference here is how much? 2.6 and 3.5. It's how much? 3.6 and 2.5. Let me do it. 3.5 minus 2.6. So the difference is how much? It's again 0.9. So what is the meaning of this? The permanent dipoles of this and the permanent dipoles of this are almost of the same strength. Look, the permanent dipole of this and this are almost of the same strength. But if you look at this one, 2.5 and 3.5, where the electronegativity difference is more here, so the dipoles would be what? Large. Large electronegativity difference, large dipoles. Right? And after bond, now I'm going toward molecule. We have two types of molecules. Diatomic molecule. Same atom, same atom, same atom. No permanent dipoles, non-polar, no electronegativity difference. But what about this? Different electronegativity difference. Automatically they have permanent dipoles. But one thing, if you look at HF and HCl, H is how much? 2.1 and 3. Wait, we can do it this way. 2.1 and 4. More larger dipoles, weak dipoles, weakest dipoles. This is what? There's a difference of how much? 0.9. There is a difference of how much? I think some 0.4 or 0.5. So more the electronegativity difference, larger are what? Dipoles. The dipoles of HF are larger than the dipoles of HCl. And then HBr is becoming very less. So we have two types of molecules, diatomic molecule and polyatomic. Diatomic means two atoms. Both atoms same, no electronegativity difference, no permanent dipoles. But if they are different atoms, there will be electronegativity difference and there are permanent dipoles. And the next topic is the polarity of polyatomic molecules. Right? And this we are going to do in the next class. Like and subscribe my channel and see you in the next lecture. Allah Hafiz.